Hello, my name is Daniel. In this video, I'm going to demonstrate a virtual tutoring environment that I've set up for helping students in several subjects including math, physics, chemistry, statistics, and even standardized testing. Although the questions we're going to practice with in this would come from math, the tutoring session would enable us to see what it looks like to get feedback, to use the board, and to illustrate with different colors. At the end of the session, you would be able to tell how effective you think it would be to have some tutoring sessions online virtually as opposed to in person. With all that is going on right now, we need to think of ways to work remotely. So let's get to the math questions that I'm going to be using to illustrate. All right. So here are the three math questions that we would use to demonstrate in this virtual tutoring session. The first question has to do with the slope and the y-intercept of the line 2x minus 4y equal to 16. And we have four options that we're going to pick the right option. The second question has to do with the x and the y-intercept of an equation, and we're going to graph it. And the third final question is about given pair of equations, trying to find the slopes of the lines and determine whether the two lines are parallel, perpendicular, or neither. So now let's tackle this question. Okay, let's get to the questions. The first one has to do with the slope, noted by symbol M, and the y-intercept, noted by symbol B, of the equation 2x minus 4y equal to 16. The key to solving this question is to realize that we have to rearrange these terms into the form y equal to mx plus b, at which point this becomes our slope and this becomes our y-intercept, right? Slope and the y-intercept. So this turns out to be an exercise in moving things around. We need to get y by itself and we need to get the 2x to the side. So I'm going to do that manipulation right here. 2x minus 4y equal to 16. Well, what we can do is to get the 2x to the other side. So we are left with negative 4y equal to 16 minus 2x. And then we're trying to get y by itself, so we're going to divide both sides by negative 4. So that leaves us with y equal to 16y by negative 1 is going to be negative 4. Negative 2 divided by negative 4 is half. It's about the same. Just for formality, you can say y equal to half x minus 4. Just swapping the terms. At which point we realize that this is our slope, this is our y-intercept. So the slope is half and the y-intercept is negative 4, which means option D among the options is what we want. Slope is half, the y-intercept is negative 4. Any questions about this? Quite straightforward, isn't it? Yes, it is. As a quick recap, we had to rearrange the equation we were given in a form that allows us to read the slope and the y-intercept. Very simple. Right. I'm very happy to work with you to show you how to solve questions in math. The second question we're going to solve, we're being told to find the x and the y-intercepts of an equation 4x minus 8y equal to 8. 4x minus 8y equal to 8. First of all, what are the x and the y intercepts? Well, if you have a generic graph with the x and the y axis, the line could be like this. Whatever way you choose, I'm just going to choose arbitrary like this. This right here, I want to use a different color to differentiate from the graph. This is your x-intercept right here, the point where the line crosses the x-axis, and the point where the line that represents this equation crosses the y-axis would be your y-intercept. Again, is it clear? When we graph the line, this is the line. This line right here is the line 4x minus 8y equal to 8. So the point where the line crosses the x-axis is the x-intercept. The point where the line crosses the y-axis is the y-intercept. Here's what is interesting about the x and y-intercept. At the x-intercept, notice that at the x-intercept, what is the value of y? Well, y is 0 at that point because y is positive above the x-axis, y is negative below the x-axis. But at the x-intercept, y has a value of 0. So we know that at the x-intercept, y equal to 0. So what that means is that if we plug in y equal to 0 into this equation and solve, ta-da! We get the x-intercept. So let's do that. So in the equation 4x minus 8 equal to 8, we plug in 0 for y. So this just means 4x equal to 8. We solve that by dividing both sides by 4, which leaves us with x equal to 2. So that means our x-intercept is the x value we got, 2, and the y value we assumed of 0. Yay! So we know that 2, 0 is the x-intercept. Never mind the fact that this illustration has the x-intercept in the negative. This was just a generic concept. It doesn't matter. We could have drawn this line like this or like this. Okay, we are not done yet. Are we done? No, we're not. We have to find the y-intercept. To find the y-intercept, I'm going to make this clear that this is the end of the question. What is different? So we know that at the x-intercept, y is 0. At the y-intercept, based on symmetry, x is 0. So we take this equation and right away we substitute. We're going to substitute x equal to 0, and then we write the rest of the equation. Okay, 4 times 0 is 0, negative 8y equal to 8. We can pretty much take that away. We divide both sides by negative 8 because we want to get y by itself, which leaves us with y equal to negative 1 because 8 divided by negative 8 is negative 1. Data, again, we find that our y-intercept is actually below. So we know that our y-intercept has the coordinates an x value of 0, we said, because it's the y-intercept, and a y-coordinate of negative 1. That's our y-intercept. So to be correct, the graph actually looks something like this. What we actually have is a graph like this. I'm going to erase this to show what we actually have. We have a graph where the x-intercept is 2. I'm going to make this a little more artistic. One, 2, that is 0, 2, 0, and 0, -1 as our y-intercept. So this is 2, 0, and this is -1. This is 0, -1. So our graph is going to look like this, just a straight line passing through these 2 points. That's what we're going to get for the line 4x minus 8y equal to 8. Any questions? What do you think? Was that simple enough? As a quick recap, it always helps to recap. To find the x and the y-intercept of a line, we take what we know about the intercept, which is that at the x-intercept y is 0, and at the y-intercept x is 0. We take those 2 crucial pieces of information and we use that to make substitutions, which allows us to find the corresponding coordinates. So make sure you have some practice on these, and just to practice and see how it feels. By the time you do a couple of questions that involve this type of substitutions, you would feel more comfortable with problems about x and y intercept, and you can do this. It's very easy to do. Thank you so much for watching this video up to this point. At this point, we're going to be talking about the third question, which is a kind of one of those questions that pulls different concepts together. So you're going to pay attention a little more, but it's not anything too difficult. The third question, without further ado, says to find the slopes of 2 lines. We have lines. The lines are 8x minus 6y equal to 5. The second is 8x plus 12y equal to -3. And we are interested in finding the slopes. The slope is denoted by symbol m of these lines. Well, and then we're going to decide if the lines are parallel or perpendicular or neither. We're going to talk about that. But before that, let's just talk about the slope. Remember we said that in the first question that if you can write an equation in the form y equal to mx plus b, then you know right away that the coefficient of x is the slope. Easy enough, isn't it? So all we have to do is to move everything, keep y on one side, and then make sure the coefficient of y is 1, because technically there's a 1 here. So if we were to start with the first question, and I'm going to jump some steps here, but you can always work this by yourself. If I moved 6y, if I added 6y to both sides, I would get, actually I'm going to do it here. If I were to add, I want to be positive, so I add 6y to both sides, because I want that to add 6y to both sides. Actually, I'm going to put it right here. And then I subtract, because I want to have y by itself. So that means I need to also get rid of the 5. And I subtract 5 from both sides. So that means 5 is going to go away. And the 6y is going to go away. So I'm going to be left with 6y equal to 8x minus 5. Right? It doesn't matter, the y could be here, it just means y on one side, the rest of the equation on the other side. at which point I divide both sides by 6 because I want to get y by itself. So y equals 8/6x minus 5/6. Remember, I'm looking for the slope, the m. So that's all this right here. This right here, the equation of the x. That is my slope. So I can reduce that to lowest terms and just say 4/3. That's the slope of the first line. 4/3. Again, you're welcome to try this by yourself. It's for the sake of space and brevity, we're a little quicker with this. Remember, we have to find the slope of the second. So the second equation says that to demarcate, I'm going to say 8 plus 12y, 8x, I believe. Yes, 8x plus 12y equal to -3. Again, we have to follow the same procedure we followed earlier, in which we want to get y by itself. But because y is positive on this side, I think life is going to be easier if I just subtracted 8x from both sides, which is the same thing as adding a -8x. In other words, I want to get rid of this so that y can be by itself. There are so many ways to go about this. Just the quickest way that appeals to you. There are different ways to get from, I would say, from from California to Texas, different interstate routes. Whichever appeals to you quickest. I'm thinking right here that to get the 12y by itself, just to take away the 8x. And the way to take away the 8x is to subtract it from both sides. So if I were to subtract 8x from here, and I subtract 8x from here, technically there's a 0x here. Even though it's not stated, there is like a 0x right here. Because 0 doesn't change anything. So this is going to go away, and you're going to have 12y equal to, again, we are adding 8x, -8x minus 3. Wow, we're very close. We want to get to mx plus b, so we want the equation of y to be 1, which means we divide by 12. And then we're going to get y equal to -8/12 x minus 3/12. Remember, the equation of x is our slope. The equation of x is our slope. And right here, this is it. If we reduce to lowest terms, this is, divide both sides by 4. -2/3. -2/3. Yes, it is. Yes, it is. 8. So -2/3. 4 into 8 is 2. So that's that right here. Now we have two slopes. Well, the rule for determining whether two lines are parallel if the slopes are equal. In other words, if we represent the slopes by m, we would say that if m1 is equal to m2. That's not the case here. 4/3 is not equal to -2/3. So we know these slopes are not equal and the lines are not parallel. The other condition is perpendicular. And I'm just going to say perpen. You know what I mean? Perpen. Well, perpendicular would be the case if one slope is the negative reciprocal of the other. So for example, the negative reciprocal of 4/3 is -3/4, which is not this. Alright? Examples of negative reciprocal will be 2 and -1/2. You see that? So for example, Negative reciprocals will be like 2 and negative 1 over 2. You see that? It's a reciprocal with a negative sign. And that's not the case here. So we know that these lines are not perpendicular. So if they are not parallel and are not perpendicular, then they are neither. So our answer is going to be neither. Neither. I hope you've been able to see by way of illustration how this tutoring environment looks. As I said earlier, because of the COVID and the need to take some precautions, more students are becoming more open to private tutoring by virtually. So this is an opportunity for you to see, by way of these 3 math questions that we just solved, what you think about working with me remotely online. I'm going to give you my email address. It's mytutor435@gmail.com. It's going to show up next. And I'm looking forward to working with you. I'm looking forward to helping you attain success. I've had about 10 years of experience tutoring students at high school, at college level, in subjects like math, college physics, college chemistry, calculus, SAT preparations, statistics, and a trial would convince you that I'm very committed to the success of my students. I'm always about understanding where the student is, the methods, asking intelligent questions to locate the student. I do everything it takes to help students improve their grade while at the same time having a good grasp of the concept, because what you understand is what is going to help you when you get into the exams or in your subsequent classes. Okay. I trust you've had a pleasant experience seeing this demo of online tutoring. We can definitely make lemonade out of lime. Out of social distancing, we can get more out of online tutoring. Most of the time, students will let me know either by email what topics they need help with, and I'll prepare a session that would help the student prepare for a test or just to stay on top of the class. You can contact me at either of these email addresses. I offer an affordable price that is even further discounted when you book multiple sessions or sessions that are relatively long. I look forward to helping you attain success.